In the today's class, I am going to explain different methods of machining. The main aim of this session to familiarize the students with the different methods of machining and instructional objectives. This session is mainly designed to understand orthogonal and oblique cutting, learn key aspects of orthogonal and oblique cutting process. Learning outcomes. After completion of this session, you should be able to understand the different methods of cutting, clear about how to machine in orthogonal and oblique methods. Methods of machining. So, orthogonal and oblique cutting are two fundamental methods of machining used in manufacturing process. Orthogonal cutting, also known as two-dimensional cutting or straight cutting, refers to the cutting process where the cutting edge of the tool is perpendicular to the direction of the cutting speed. Oblique cutting, also known as three-dimensional cutting, involves a cutting process where the cutting edge is inclined at an angle to the direction of the cutting speed. The manufacturers analyze these factors to determine the most suitable cutting method for a given machining operation. Orthogonal method of machining. Now let us see this diagram. Okay, so it consists of how the workpiece and the tool is aligned. Okay, now you can see that the tool is moving. This is the tool move and the angle. So this angle is perpendicular to the direction of the chip. So that is the velocity vector. If you see that the velocity vector, so that vector is perpendicular to the edge of the cutting tool. Okay. So in that configuration, this type of machining we can call it as a orthogonal method of machining. So the workpiece is held in place and cutting tool is positioned perpendicular to the direction of the cutting speed. So it's worth noting that the orthogonal method is a simplified model of machining, and real world machining operations often involve more complex factors and considerations. So you can clearly observe this, how the chip is flowing. Okay, so the chip is flowing on the surface of the tool. Okay, and this tool edge is perpendicular to the direction of the chip. So that type of machining is called as a orthogonal method of machining. Next we will see the oblique method of machining. Now you can clearly observe here. Okay, so the direction of this velocity vector, and this edge of the tool, these two are having some inclination. Okay, so that inclination is the lambda s. Okay, so earlier you have seen these two are having the 90 degrees angle, that is in the oblique the method of machining, orthogonal method of machining. In oblique method of machining, it is having some inclination. So the tool is moving with an angle. Okay, with an angle. So the workpiece and chip also, you can see that this entire the surface of the chip is not touching the surface of the tool. Okay. So this type of the machining is called as a oblique method of machining. So oblique cutting, also known as three-dimensional cutting, involves a cutting process where the cutting edge is inclined at an angle to the direction of the cutting speed. So in this case, the primary cutting edge removes materials by both shearing and ploughing actions. So now here this material, how this material is removed, that there is a combination of shearing and the ploughing action. Because of the inclined, the tool will contact the material, and so because of this two actions, the material is removed. And also you can observe that the entire surface of the chip is not touching the surface of the tool. Okay, so in that case the frictional the losses are very less compared to the orthogonal machining, whereas in orthogonal, because this edge is perpendicular to the chip formation and the entire the surface of the chip is touch the surface of the tool, so that there is a frictional forces are acting, and it will have the more power or more force is required to get the machining. That is the main difference of the ortho method of machining and oblique method of machining. So now we see that you have observed both the machining. What are the differences between orthogonal and oblique machining? We will see the first difference, the tool orientation. Already we have seen in orthogonal machining, the cutting tool is perpendicular to the direction of the cutting speed, while in oblique machining, the tool is inclined at an angle to the cutting speed. So chip formation. So orthogonal machining typically results in continuous chip formation, whereas oblique machining can result in various chip forms such as continuous chips, segmented chips and discontinued chips, etc. Different chip formations are possible in oblique machining. So cutting forces, the magnitudes and direction of cutting forces differ between orthogonal and oblique machining due to the varying tool orientations. The forces in orthogonal machining are mainly perpendicular to the cutting edge, while in oblique machining they have both perpendicular and tangential components. So cutting edge engagement. In orthogonal machining, the primary cutting edge fully engages with the workpiece material, while in oblique machining the cutting edge engages partially due to the inclination angle. The surface finish. The surface finish achieved in orthogonal machining is typically smoother and more uniform compared to the oblique machining. So which can result in varying surface qualities depending on the chip formation and tool engagement. So next is the cutting parameters. If we compare the cutting parameters of both orthogonal and oblique machining, the optimal cutting parameters such as cutting speed, feed, rate and depth of cut may differ between orthogonal and oblique machining due to the variation in chip formation and cutting forces. So the tool geometry, coming to the tool geometry, it's used in orthogonal machining usually consists of a single cutting edge, while in oblique machining tools may have multiple cutting edges or complex shapes to accommodate the inclination of the tool with the reference to the workpiece. So material removal rate. In general, oblique machining can achieve higher material removal rates compared to orthogonal machining due to increased tool engagement results from the inclined angle. So the tool life, coming to the tool life, due to the differences in cutting forces and chip formation happening in both the orthogonal and oblique machinings, the tool life can vary between orthogonal and oblique machining. Oblique machining may lead to higher tool wear rates, requires more frequent tool changes because already I told you the entire the surface of the chip is forming on the touching on the surface of the tool. So the wear and tear is more in case of the orthogonal. So machining stability, if we compare the stability point of view, the stability during the machining including the prevention of vibrations and chartering can be affected differently in orthogonal and oblique machining due to variations in cutting forces, chip formation and tool engagement. So the coming to the summary of this session, so in this session we understand how the orthogonal and oblique method of machining is taking place and how we can the differences of these two methods of machining is studied. Thank you.